Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR IT Hyderabad. Today I am going to explain about the transient or time response of undamped second order system for unit step input. When we are going to apply the unit step input for the undamped system, what is the response of that system? Now we are going to see in this lecture, right? Coming to today's session overview is just observe the expression of time response of undamped second order system for unit step input, and also one more point is output or response of that undamped second order system graph for the graphical representation, and also derive the expression for time response of undamped second order system when we are going to apply the unit step input. Now we are going to see all these, right? Next, coming to here. Now I am going to consider the one closed loop transfer function with unity negative feedback control system, that is the second order closed loop system. Here, see, observe, in this circuit, the input is R of S and output is C of S. The G of S is equals to here, G of S is equals to omega n square divided by S into S plus 2 zeta omega n. That means this is the order, second order system. In denominator part, the maximum power of the S domain is nothing but the order of that respected system, right? Here, see, what is the transfer function for this system is nothing but here unity feedback. This is unity feedback is nothing but the negative H of S is equals to 1. The negative feedback here we are having in this circuit, and unity feedback means H of S, the feedback gain is equals to 1, right? Now here the closed loop transfer function C of S divided by R of S is equals to this G of S divided by 1 plus G of S 1 plus here negative sign is there, so negative feedback, so 1 plus G of S into H of S, where H of S is equals to 1, right? So now here I am going to consider G of S is equals to omega n square, G of S equals to omega n square divided by S into S plus 2 zeta omega n. Here also, now just I am going to write this equation again into, or else omega n square divided by S square plus 2 zeta omega n into S. This is also second order system. Just solving this, omega n square divided by S square plus 2 zeta omega n S. This is G of S. Now I am going to substitute in place of G of S. G of S divided by 1 plus G of S, and H of S is equals to 1, right? So here omega n square, this is by solving this one directly we are going to get this omega n square divided by S square plus 2 zeta omega n into S divided by 1 plus omega n square divided by S square plus 2 zeta omega n into S, omega zeta n into S, right? Here now I am going to write here this one equation. C, once C of S is equals to, or C of S divided by R of S is equals to, from this omega n square is over G of S, omega n square divided by S square plus 2 zeta omega n into S divided by 1 plus omega n square divided by S square plus 2 zeta omega n into S. So here just a common S square plus 2 zeta omega n S, and here now I am going to finally omega n square divided by S square plus 2 zeta omega n S divided by S square plus 2 zeta omega n S plus omega n square divided by S square plus 2 zeta omega n S. Okay, omega n square both are get cancelled. Omega n square divided by S square plus 2 zeta omega n S. Finally, this is the transfer function of unity feedback second order closed loop system. Here this one, see, omega n square divided by S square plus 2 zeta omega n S plus omega n square, right? Here And also directly we are going to calculate this closed loop transfer function when we are having the unity feedback system. That is directly this is the g of s. Simply the transfer function of this directly we are going to write r of c of s divided by r of s is equals to, here in gain g of s is equals to omega n square divided by s square plus 2 zeta omega n s, right, denominator. Simply numerator part is directly adding with the denominator part, you will get the transfer function for any unity feedback system. Simply here see omega n square divided by s square plus 2 zeta omega n s plus omega n square. This is the transfer function directly we are going to write for every unit feedback system. This one we are going to get, that is the transfer function of the given second order system. Here same. And also here when we are going to substitute, we are going to get this one in g of s, right. This is already I explained in previous slide. See the power of s is 2. Here see, observe, in denominator part the power of s is equals to 2 in denominator term. So hence the above transfer function is the second order and the second order system. So this is the order is nothing but the maximum power in denominator part or in denominator polynomial. The maximum power of s is known as the order of this system, so second order system. Now here in this lesson or in this lecture we are going to see, consider the unit step input, right, unit step input for undamped system. For undamped system, here see undamped system we have a, based on the damping ratio we have a different systems are available in control system. So here we are consider only for undamped. Undamped is nothing but the zeta value is equals to 0. Zeta value is equals to 0. The standard form of closed loop transfer function or second order transfer function is omega c of s divided by omega c of s divided by r of s is equals to omega n square divided by s square plus 2 zeta omega n s plus omega n square. This is our second order transfer function or a standard form of closed loop transfer function of second order system. For undamped system, zeta equals to 0. For unit step we are going to consider unit step r of t is equals to, here see for unit step r of t is input is equals to 1. So input is equals to 1. Apply the Laplace transform to this input or unit step input. Just we are going to quote this r of s is equals to 1 by s. After apply the Laplace transform, we are going to get this r of s equals to 1 by s. Here this one. Next here the response in s domain is c of s. Here c of s is equals to, we know r of s is equals to 1 by s. Here c of s directly this one is I am going to write here zeta equals to 0, right. Zeta equals to 0 means here substitute zeta equals to 0 in this closed loop transfer function or second order system. This term is completely going to be 0. So that means that directly we are going to get this equation c of s divided by r of s equals to omega n square divided by s square plus omega n square. When we are going to substitute the zeta equals to 0, you will get this one transfer function omega n square by s square plus omega n square. When the input is unit step, this is in after Laplace transform, the r of s equals to 1 by s. Here in s domain the response of this system is c of s is equals to r of s into omega n square divided by s square plus omega n square. Here see this one, here also there this one. Okay, when we know this r of s, so r of s equals to 1 by s, just substitute in place of r of s 1 by s. This equation you are going to get, right. This is the c of s, response in S domain, C of S, by using partial fraction expansion for this equation. Now we are going to here omega n square divided by S into S square plus omega n square, right? Here a by S plus B by S square plus omega n square by using by partial fraction a by S plus B by S square plus omega n square, simply B by S square plus omega n square. For the calculation of this A and B, now we are going to calculate A and B. For that, A is obtained, A value is obtained by multiplying the C of S by S, C of S by S, because of in A divided by S is there. So S equals to 0 only. So when we are going to substitute S equals to 0, and here in denominator S term is available, so S is just multiplied by the C of S. Here C of S, S, A is obtained by multiplying C of S by S and letting S equals to 0. Here we know A equals to C of S. Already we know that C of S equals to omega n square divided by S into S square plus omega S into S square plus omega n square. So this one is the C of S, right? Here C of S into S, S is multiplied by C of S, letting S equals to 0, substitute. Here just simply see, observe this one here, omega n square by S into S square plus omega n square into S, letting S equals to 0, just to substitute this S and S both are get cancelled, and S equals to 0, substitute, this term is going to be 0. Finally omega n square by omega n square, you will get, both are get cancelled, the value is going to be 1, right? So A equals to what? 1. We are going to get the A equals to 1, and B is multiplied, same procedure to apply for the calculation of B value. B is multiplying C of S by, in denominator of B is what? S square plus omega n square, right? So C of S by S square plus omega n square, and letting S square is equals to, here S square plus omega n square is multiplied with the C of S, right? Here S square plus omega n square, it is equals to 0. That is nothing but S square equals to minus omega n square. Square root both cancel. Here S equals to minus j omega, here S square. So S square, so S equals to what? Minus omega n square and root. Here root square both cancel, and here S equals to, here minus j square equals to minus 1. So here minus 1 is there, minus 1 into omega n square, right? So minus 1 equals to, directly I am going to write the j square and omega n square. J square and omega n square, square both are get cancelled. So S equals to j omega n. Here S equals to j omega n. S equals to j omega n, right? So here just I am going to write this S term in above. Root, square root both cancel, right? So finally I am going to get the S equals to j omega only. So letting S equals to j omega n, substitute in that equation, or S square equals to minus omega n square, or so, no problem, anyone. So here see, C of S, we know this one is our C of S, omega n square by S into S square plus omega n square, and it is multiplied with the denominator of B is S square plus omega n square. So S square plus omega n square, this term and this term both are get cancelled. So omega n square divided by S, omega n square by divided by S, letting S equals to j omega n. S equals to j omega n, just to substitute j in denominator, so it is comes under the numerator part is minus j. So minus j omega n, 1 omega n is both cancelled. So 1 omega n is minus j omega n. J omega n is nothing but what? S. So minus S. So now B equals to minus S, and A equals to 1. A equals to 1. We know the A and B values. After that, just substitute A and B values in this equation. In this equation, now we are going to C of S equals to omega n square by here. Substitute A and B value in place of A and B of this equation. Just write here. See, we are got minus S, right? So A by S plus B by S square plus omega n square. So now here A equals to 1. So write 1 by S minus, here minus S is there. So minus B equals to minus S. So S and minus S square plus omega n square. This is, see here, now we are going to calculate the response of that system is in the form of time domain only, right? Or time response or transient response. So now we are going to apply the inverse Laplace transform. Inverse Laplace transform to the equation of this C of S here. Now this equation I am going to write the or apply the inverse Laplace transform to the S domain equation converted into the time domain equation. Right here, see, observe the 1 by S Laplace, inverse Laplace of 1 by S, or Laplace of 1 is nothing but 1 by S, right? Laplace of 1 by S is equals to 1 by S. Inverse Laplace, this one, Laplace here comes this after equating. Inverse Laplace of 1 by S is equals to 1, right? 1. And here Laplace of cos omega t. These the formulas are very important. You can remember all these, right? Laplace of cos omega t equals to here cos omega. So here we are get the positive. If you are having any sin omega t, S square minus omega square, right? Here see, observe, cos omega t S divided by S square plus omega square. S square S divided by S square plus omega square. Omega square. So cos means here S. If it is we have sin, here omega, right? S divided by S square plus omega square. These two are the formulas. Just observe here. See, S divided by S square plus omega n square. This is comes under the cos omega t. Cos omega t, and here 1 by S. 1 by S is after Laplace in time domain. 1 by S, inverse Laplace of 1 by S is nothing but 1. Inverse Laplace of S divided by S square. Simply inverse Laplace of 1 by S is equals to what? 1. Inverse Laplace of cos omega t, sorry, inverse Laplace of S divided by S square plus omega n square. Omega n square or else omega square. Omega n square or omega square, that is equals to cos omega n t. Cos omega n t. Just substitute these two. Apply the inverse Laplace to this equation. Apply inverse Laplace transform. Apply inverse Laplace transform to the above equation, this C of S equation. Now we are going to get C of S of Laplace is nothing but C of t, which is in the form of time domain, right? T of C of t is equals to inverse Laplace of 1 by S minus S by S square plus omega n square. That is 1 by S is nothing but 1. S by S square plus omega n square is nothing but cos omega n t. Here the response of undamped system for unit step input is 1 minus cos omega n t. 1 minus cos omega n t. This is the response of second order undamped system. Undamped system is nothing but the damping ratio is equals to 0, right? Undamped is nothing but the damping ratio is equals to 0. This is the response or output of the second order system when we are going to apply the unit step input, right? Here coming to the graph, here just we are going to observe when we are going to apply the input is unit step. This one is the unit step signal. Now unit step signal when we are going to apply for the any undamped or undamped system, now we are going to get this output. This is our response of a unit step. here response of undamped second order system for unit step input. This is here, this is the sinusoidal signal, so continuous. Okay, now see here, observe this signal, just we are observed that response is going to be completely oscillates, some completely oscillates like that. Okay, okay, completely oscillates like that going on. So this is completely oscillatory, completely the response of the undamped second order system for unit step input is completely oscillatory. Just here see, you, this equation from, that is the equation is nothing but time domain response of undamped second order system in Laplace or inverse Laplace of 1 by s minus 1 by s square plus omega n square, that is nothing but 1 minus cos omega n t. From this equation, input is unit step and output is sinusoidal signal, that is completely oscillator. See here, observe, for this equation the response of undamped second order system for unit step input is sketched in figure. Just this is the response, and observe that response is completely oscillatory, because of it is going to be oscillating. So this is the completely oscillatory response of undamped system when we are applying the any unit step input signal. This is about the undamped second order system response when I am going to apply the input as a unit step input, right? This is the graph. This is the graph or response of the undamped second order system. After the derivation of the undamped second order system, this is the time response, that is the transient or time response of the undamped second order system is 1 minus cos omega n t. 1 minus cos omega n t. These two are, this equation is very important, and graph also here. From that graph we observe the output of that input undamped second order system for unit step input is completely oscillatory. You can remember all these words also. For undamped is nothing but what, zeta equals to 0. Zeta means what, damping ratio, right? Based on the damping ratio, the system can be classified into the 4 categories. Already in previous session, previous class I explained all these point, right? In this session only we observe the what is the response of the undamped second order system for unit step input, that is zeta equals to 0. For this is the output and this is the response of graph, right? This is about the, and here just observe one thing, for step input is that is signal, for unit step input is just multiply here. Unit step unit step is nothing but this one, but step input is nothing but a is multiplied with that signal, a is multiplied with that. Here see, observe, but in practical system, for every practical system has some amount of damping. Practical systems having some amount of damping is available, hence undamped system does not exist in practice, because of practical systems have some amount of damping is available, some of amount is available in already. So hence undamped systems are does not exist in practice, right? So that's why now we are just here observe from that output, and that equation is this 1 minus cos omega t unit step input. For this output, when I am going to multiply the step value is a, multiply the step value of unit step, we get the unit step output. Just here observe the response of undamped closed loop second order system for unit step input. For step input of step value a is should be multiplied by a with the unit step equation or unit step equation, that is 1 minus cos omega t. After multiply the a step value, we are going to get this step response, right? This is about the transient response or time domain response of the, or time response of the undamped second order system for undamped second order system for when we are going to or for apply the unit step input. For unit step input, this is the these are the equations are very important, right? This is about the transient or time response of this undamped second order system for unit step input, right? I hope you understood every point. I think these are the very important for your technical exams also, right? Thank you.